right, so I'm still having issues, so we'll see how this goes. All right, so x to the fourth is greater than x. And again, if you have a graphing calculator, you could just graph this as y1, this is y2, and use second intersect, kind of get a feel for what's going on, and then try to find where the one function is greater than the other. But say I don't have a calculator. So I'm going to bring everything over to one side, set it equals 0. I'm going to factor. And at this point, you either need to have your cubics memorized, or you have to at least know that if it's like x cubed minus 8, that x minus 2 is going to be a factor. If it's x cubed plus 8, x plus 2 would be a factor. And then you're going to have to, do long division or something, synthetic division, to figure out the rest. So I don't memorize this. So in synthetic division, your 0 goes out here, not your factor, but what causes 0. And let's see, I have 1x cubed, 0x squared, 0x's, and negative 1. So I'm going to bring down my 1, multiply, add, and multiply, add. And I knew I would get a remainder of 0 because I know that x minus 1 is definitely a factor. So I get that. So this would be x squared, x, and then 1. So if you're like, ooh, maybe that factors, well, obviously if it factored, the cubic would have not a trinomial for the second part that you memorized, but if you're not sure, you could always do quadratic formula, opposite of b plus or minus square root of b squared minus 4ac all over 2a, and right away you can see you're going to get an imaginary number there. So so that's not going to factor more. And like I said, if it really did, then why would people memorize that this comes out and there's leftover? So wouldn't make sense. All right, so we are going to figure out when all this and is greater than 0, and we're not going to factor it. So we're going to kind of see. So obviously we have a key point at 0, and we have a key point at 1. And so then the question is, what kind of intervals do we have to check? So why don't you think about that for a second. So we're not going to graph it this time. We're just going to make a x number line with some key points, and we're going to test different regions. So think about what those would be, and then I'll come back and we'll finish. All right. So we have our key points. So we have the 0 and 1. And you could look for things like intercepts, but if you notice, if you view this as a function, and again, I know we have the greater than, but like 0, 0 obviously is going to be both an x and y intercept, and this is 1 is the other x-intercept. So 0 is an x-intercept, 1's a x-intercept, but then if you think of the original, excuse me, 0, 0 would also be the y-intercept. So x and y-intercept, and then we have another x-intercept. So these are kind of our key areas to kind of sub in. And again, if you're not sure what's going on, it doesn't mean you can't sub in more points. So say you're like, I don't know, I don't trust the system. All right, so sub in a negative 2. And so then you're like, okay, so I have 16 minus a negative. Yep, that's positive. That's good. And so you're like, I'm just not sure. Maybe I need to test something else in here. All right, so let's plug in a negative 1. So you get 1 minus negative 1, 2. Yep, still positive. So, as long as you solve, sub in anything on that side, it's going to be positive. All right. And again, 0 is not included because we have a greater than there. So this stuff is this is what we're looking for. This is all greater than 0, so that's good. All that's going to be fine. All right. So now we have to test something kind of in the middle here. All right. So, I don't know, like a half seems to be logical to me. All right, so a half to the 4th power, right, is what, 1/16. And then you're subtracting a half. So times what, 8 times 8. So that's a negative, what is that? What do I have? 1/16 minus 8, so negative 7/16, something like that. But again, a negative 7/16 is not greater than 0. So this is negative, and even if I made a dumb mistake, I obviously know it's negative. That is the main concern here. So not the exact answer, just the fact that it's negative. All right, so then let's go over to this side. So say I put in a positive 2. Again, I get my 16 minus 2, which is positive, so that's nice. And if you're like, I just want to sub something else in, okay, well, 3 to the 4th power minus 3, yeah, still positive. And so it's just going to become a bigger and bigger positive number. Now, again, 1 is not included because of the issues with the greater than. So even though I didn't graph it, I kind of am like, okay, I have a feel for what is going on here. So if I want to write my interval notation, it looks like I'm going to have to erase a little bit. I didn't like that, because I have to pick the one. All right, so if I erase some of this stuff here, all right, and then there's that. So pens, oops, I lost my pens. Well, this is lovely. Ah, there we go, maybe. I think so. All right, so -2 to 0, right? Those all yielded nice positive answers, right? And then in this middle part, it was negative, so I have to skip over that. And then over here, on this positive side, again, I'm good. So on that one, my factors yielded x-intercepts at 0 and 1, but when I looked at the function, as far as if I viewed this as, you know, f of x equals x to the 4th minus x, all right, if I substituted in 0 to the 4th minus 0, that's also my y-intercept there. So, you know what I mean? So if I sub in x equals 0 and see what happens, that's my y-intercept. But that was a duplicate. So that's why I didn't need a y-intercept in there. I had my x-intercepts. Obviously, there's no asymptotes because everything's on the level. And usually we would look for the y-intercept as kind of another key thing that might be happening. But here I didn't have to because it was already handled there. So that's kind of how you can solve one without having to graph it. And, of course, the cubic factoring is kind of a good review as well.